Find all the inflection points of the function f, but f double prime is given. F double prime of x is x times x plus 1 squared times x minus 2. To determine the inflection points, which is where f double prime changes its sign, we only need to take the second derivative and set it equal to 0. This is the zero product, so we set the first factor equal to 0, the second factor, which is a multiplicity of 2 equals 0, and then x minus 2 equals 0. And so we get x equals 0, x equals negative 1, and x equals 2. These are not the critical points, but they are the cut points. They cut the number line negative infinity to infinity into 4 intervals: negative 1, 0, and then 2. And then we test the sign of f double prime. From negative infinity to negative 1, we pick any number, x equals negative 2 for example, and then we plug this into the second derivative. We don't need to test the factor x plus 1 squared because that factor is always positive. Plug negative 2 into x, we see that this is a negative number, and then negative 2 minus 2 is also a negative. A negative times a negative is a positive number. So f double prime is negative on the interval negative infinity to negative 1. From negative 1 to 0, we pick x equals negative 1/2. And again, we do not need to check the sign of x plus 1 squared. We only need to check the sign of x times x minus 2 to determine the sign of f double prime. If we plug x equals negative 1/2 into this, we have negative 1/2 times negative 1/2 minus 2 is negative. So this is a negative times negative. And so f double prime is positive on the interval negative 1 to 0. We then pick any number between 0 to 2, x equals 1, and plug this into the product x times x minus 2. X is positive because x equals 1. 1 minus 2 is negative. A positive times a negative is a negative. And so f double prime is negative on the interval 0 to 2. From 2 to infinity, we pick x equals 3, and we see that this is 3 times 3 minus 2, and so f double prime is positive. F double prime changes its sign only at x equals 0 and x equals 2, and so we will find the inflection points at these two x values. Now usually we want to have the x and the y coordinate for the inflection points, but in this case we don't have f of x, so we cannot find y, but we know the location of the inflection points. We don't know how high or how low the inflection point is, but we know where it is. The inflection points occurs at x equals 0 and x equals 2.